Welcome back. In this episode, we build an electronic circuit machine, upgrade our storage with super chests, and build our very first MV circuit. This is Star Technology. Let's get into it. So this is the recipe for the basic electronic circuit, as built by the circuit assembler. We still need the resin printed circuit boards, the resistors, the vacuum tubes, and the red alloy wire. So the thing that makes constructing basic electronic circuits difficult is not the final craft from all of these components. It's nice to have the circuit assembler to do it for us, but that's not the hard part. The hard part is making all of these individual components. There's a recipe for building resistors in the assembler, which uses coal dust, fine copper wire, and glue. So we have glue left over from our production of rubber, so that's not a problem. Coal dust can be made simply by macerating charcoal, and fine copper wire, we already have a wire mill that can make that. So this process here can be quite easily set up. With the charcoal, we're going to need to macerate it, so we're going to need a macerator. So a macerator is pretty simple: electric piston, electric motor, some diamonds, tin, a couple of these circuits, and a machine hull. Preload that up, hook up the pipe. Macerator only has one input, so we don't need to worry about filtering it. We'll use a pusher upgrade. We're going to have to configure it to point north, so we'll put that in. And that is now macerating very quickly, actually. That's pretty cool. We'll build some pipes that will feed it into this assembler when it's here, but for now I'll just leave that. So next we're going to need the wire mill. So we'll put a wire mill here with some chest for copper ingots and feed it into there. So this is what the wire mill looks like. A lot of electric motors in this one. So place that. This will be the wire mill. Program circuit 3. Pusher upgrade in there, so that also has to go north. That's now feeding into there. That should be making our fine copper wire, which it is. Excellent. Chest for the output. Assembler. Now, here we will need filters because we don't want this to fill up. We want it to just take some of this and some of that. So this side here, we need rubber arm, filter to import, keep exact, fine copper wire. And now we'll do the same for this one. The lower face, arm in, filter, import, keep exact, 64 charcoal dust, and then set this to auto output. Now we have the fine copper wire and the charcoal dust coming into here. All we now have to do is supply the glue. So we need to configure that to output. And the reason why I've done this is I'll build another assembler up there, so we'll pipe it into both machines. That is getting glue. So it's got all the ingredients it needs. The last thing it needs is power. And so that should start making resistors. Excellent. And now we just need to set it to auto output. And now we have a resistor making machine. That's done. So next up we want to produce the resin printed circuit boards. This is an annoying recipe just because of how much copper wire it was taking us to make. So we just need to supply wood planks and copper foil. We can make copper foil with a bender, so this will need to be a bender. Electric pistons, circuits, electric motors. Okay, we got that. So replace the basic bender. Get this chest in, wood planks, lock that. So we'll have to branch this pipe off here. The recipe for foil is program circuit 10. Now we need to set this output. That's producing the copper foil. It's not outputting because I haven't set the item filter in here. 16 copper foil to go in. So we want to filter on that side as well. Let's say 32 planks in output. It should automatically output there. And now all we need to do is put a pusher here. We want it to push up. That's now feeding into there. So we've got the two ingredients there. We need to hook up some glue. So that's producing resin printed circuit boards. Wow, we've got so many resistors already. That's cool. Perhaps the only problem we might have is that this resistor making machine will steal a lot of that copper for itself when we want it to sort of go through there. But I guess we can limit that by not supplying it with charcoal, because then that machine will fill up and stop, sort of like it has here. But yeah, okay, so now we're going through using the glue that we had as a byproduct of this process in here. So that's 2 of the steps in the creation for circuits. All right, so now that we've automated the resistors and the resin printed circuit boards, it's time to tackle the other side of this room, which is going to be for vacuum tubes, for steel bolts, and finally the circuits themselves. This is the recipe in the assembler for the vacuum tubes. So glass tubes, steel bolts, copper wire with a programmed circuit. So what we've got here is a glass dust manufacturing setup. So if we're crafting glass dust manually, it's quartz sand and a tiny pile of flint dust. If we're using a mixer, the recipe is slightly different. So 4 quartz sand and a small pile of flint dust makes 4 glass dust. It ends up using the same number of resources in the end, but it's just slightly different because it doesn't use a tiny pile, it uses a small pile. The problem we have is that the macerator will produce flint dust. So we need a way of turning it into a small pile of flint dust. And so that's where the packer comes in. The packer can turn flint dust into a small pile of flint dust, which is exactly what we need. The flint will go into the macerator, turn into flint dust, come into the packer, turn into a small pile of flint dust, and go down into the mixer. The sand will go into the macerator, turn into quartz sand, be sent through the pipe into the mixer, and that will produce glass dust. So the glass dust will move into the alloy smelter, where it will be cooked along with a casting mold that will turn it into the glass tubes that we need. Now I've got a pipe here that takes the glass tubes all the way around into the assembler. Next up, we need to create steel bolts. To make steel bolts, we use a cutter with steel rods as an input. However, we also need this lubricant. That's what this other part of this machine is for. So to make lubricant is quite simple. We need to put seed oil into a distillery. So 24 millibuckets of seed oil will create 12 millibuckets of lubricant. What's missing from that is seed oil. So how do we create seed oil? Seed oil can be made in an extractor from pumpkins, and it creates 6 millibuckets of seed oil. And we have a ready supply of pumpkins already down there. So that's what this pipe here is. The end result of these two should be all the ingredients we need to make the vacuum tubes. And once we have the vacuum tubes, we come to this last station here, which is the circuit assembler. The recipe in the circuit assembler looks like this. So we have tin as a liquid, resin printed circuit board, resistors, red alloy wire, and these vacuum tubes. I'll pipe in the liquid tin and have an output, which is what you can see here. But all the other components I'll just carry in here and just place. And that'll be basically the crafting. So that should do it. So to make liquid tin, all we've got to do is put tin ingots into an extractor. For this build, we're going to need a few machines that we've not encountered before. So we've never used a packer or a mixer yet. We also haven't used a distillery or a cutter. And also, obviously, the circuit assembler when we get to that. That's going to be the hardest part. So mixer is pretty straightforward. So glass, some circuits, machine hull, electric motor, and a tin rotor. And we're also going to need a packer out of circuits. How ironic. So this is the recipe for the packer. So some wooden chests, some circuits, rubber arm, conveyor module, and some tin cables. There we go. Basic packer. So the last thing we're going to need for this is a casting mold for making balls. We just need an empty mold and put the hammer in there. So we'll start off with the 2 macerators. Need to configure these to auto output. I've already pre-configured this with a pusher upgrade to push into there. Let's do the packer next. The packer will need to output down, and then the last thing we need is this mixer. What we're going to need to do is, because this has multiple slots and there's 2 inputs, we don't want it to fill up with one ingredient over another, so we're going to have to put robot arms in just to manage that. So we're going to need one on the top face. That'll be the small flint. Import, keep exact, like that. So a small pile of flint dust will now go into there. And then same thing here, import, keep exact, put that in, quartz sand. So one thing I need to do here is actually set the program circuit. in the packet is program circuit 2. Alright, so now we put the quartz sand and the small pile of flint dust we got in there. It's starting to process. So that's good news. So next up we need the alloy smelter. Place this in here. Now that's already set to auto output. So what's missing is the casting mold. We'll just need to tell it to output automatically. And now we're getting glass tubes. So next up we need to tackle the steel bolts. So we're going to need a distillery, an extractor, a lathe, and a cutter. Lathes are pretty easy, but those 3 other ones we haven't built before. And the cutter is particularly difficult, so we'll come to that last. Okay, so this is the basic distillery. What are we missing? We're missing circuits. Let's build some more of those. Ironically, the process of making these machines is actually using up a lot of these electronic circuits that we already have, which is pretty painful. But okay, so basic distillery. Next up, we need an extractor. Looks like that. So it turns out we've got all the components for that, which is handy. So let's get these installed. Distillery goes down here. Now that's probably going to start filling with stuff as soon as I place that in, so that will be interesting. Disconnect that because we don't want that plugged in. So as you can see, that's already pulled pumpkin seeds in. We want this to output to the left. So next, basic extractor. So this one we do want to have pumpkin seeds, and as you can see, it's already working. So it's producing the seed oil. So we will have that output downwards into this machine here. In this one, we need program circuit 1. So set that. And that is now producing lubricant. So quite quickly from the looks of it. So that's good. That section's done. Next up, we need a lathe. So that has already been configured to push down. This machine here will now then need to put its output down as well. All right, that's producing the steel rods that we need. We've got the lubricant here, the steel rods. Now the problem we have is this cutter. What makes the cutter difficult is the blade that it uses. We have this thing called cobalt brass buzzsaw blade. Cobalt brass is made from some brass, some aluminium dust, and some cobalt in a mixer. So we don't have a spare mixer, so we'll have to create another one, but that's fine. And we have brass ingots, so we can just macerate those. We've got the cobalt. However, we do not have aluminium. So we need to figure out a way to get aluminium. We have a few different options. Sapphire, in particular, these 2 ores are made of aluminium and oxygen. Either of them will work, crushed green sapphire and crushed sapphire ore. We've got more of the blue stuff, so let's grab a few stacks of that. How do we process that is the question. If we macerate crushed sapphire ore, we get an impure pile of sapphire dust and 14% chance to get aluminium. So if we put enough crushed sapphire ore through a macerator, we'll get aluminium dust. Because we only need like probably 8 or 16 pieces of aluminium dust. So that should be doable. The other option is, once we have the impure pile of sapphire dust, we can actually run that through a centrifuge, and we have another chance to get some more aluminium dust out of it. And also sapphire dust, which seems like a good process, those 2 together. So maybe we'll do that. Let's macerate them and then centrifuge. Oh, geez. So that's going to be pretty slow, but we'll come back to that, I guess. So I'm not sure exactly what's going on, but the basic macerator has been working on these crushed sapphire ores for a little while now, and it's produced 54 impure pile of sapphire dust, but no aluminium. Even though the recipe here for the macerator says that crushed sapphire ore goes to impure pile of sapphire dust with a 14% chance of getting aluminium dust, that has not happened. However, the forge hammer can also process crushed sapphire ore into impure pile of sapphire dust, but it takes 0.5 of a second instead of 20 seconds. What I've tried then is putting the impure pile of sapphire dust through the centrifuge, which is supposed to produce sapphire dust and aluminium dust, and that has produced aluminium dust. So that's how we're going to have to do it. Get the forge hammer to do it instead because it's much quicker, and then I'll load up the centrifuge with that impure stuff. And so, as you can see, we're getting some sapphire dust, but also aluminium. So that's the important thing. And we have another mixer. what do we need? We need brass, we need aluminium dust, and we need cobalt. That produces 9 cobalt brass. So probably need 2 lots. So actually we don't even need much aluminium dust at all because this produces so much. That's probably more than we need actually. I think we just needed a single piece of aluminium dust. We needed program circuit 1. Some brass in. And some, not sapphire dust, cobalt dust. Okay, that's mixing. It's a bit slow from the looks of it, but we'll just wait for that to finish. Okay, so now we have some cobalt brass dust. We just need to smelt it somewhere. I'll just use my electric furnace. If you come to build a cobalt brass buzzsaw blade, then one single piece of aluminium dust I think will work for you. So there's a few different ways to do that, but yeah. What the heck? Okay, yeah. You do you. That's what happens, man. Like, you can't just be hanging around up there. Jeez. Grab some of these ingots, put them into the bender. And now we have a cobalt brass buzzsaw blade. So what do we need to make the cutter then? We need some more circuits. We need some more tubes. Need some more bolts. Okay, well, that's... Oh, jeez. Come on, man. I'm working here. All right, we have the basic cutter. It should start working, yeah. We've got the lubricant, we've got the steel rods going in, and we are producing steel bolts. So let's set this to output. And now we've got the steel bolts. This is looking pretty good. So now the only step we've got left is to produce, it's just the wire. So nice and simple. So we just need a wire mill to go into there, and then we need the assembler. Lots of parts needed. Okay, so we need the robot arms. It's always circuits. So we need lots of circuits, which means we need vacuum tubes, ironically, because that's the process that we're building now. Okay, so we've run out of steel bolts, but our new steel bolt process should be up and running. Look at that. I should lock that. So we're actually using the half-finished process to help us finish the process, which is kind of cool. We're getting there. We're slowly getting there. This is going to really set us up. There we go. We won't have to worry about any of these circuits in the future. Just load up with raw materials and then let it do its work. Done. So, as before, I've already pre-configured this to push west, which is the direction we want to go. Put the wire mill in. It's filling up the power. Don't have any copper in there, so that's all right. And we want it to automatically output on that side. We also want program circuit 1. So it's producing copper wire pretty quickly. All right, next we have the assembler. So we'll place the assembler in there. So that's already filling up copper wire. Now we are going to have to put in a filter on that. So that's what this is for. Copper wire. That should limit it to 16. So we'll limit this to 16 steel bolts. So that should be coming through once I set this, I create a pusher. So we want to configure the pusher to push east. Done. So this needs to go east as well. But before we place that in, let's make a filter. Filter import. Keep exact. And then say 16 glass tubes. Place that in there. So that should start feeding in, which it is. So now we've got copper wire, steel bolts, and glass tubes. We just need program circuit 1. So if we were able to supply it with some liquid red alloy, this recipe, we'd get 1 more vacuum tube. But we've run out of connections, really. Like, I could run a pipe off the front. It would look pretty ugly. Do we really care about that 1 extra one? I don't think so, because we'd have to build another extractor. For the moment, it's not worth it. Maybe when we get to the annealed copper, we can double it. That would be useful. But at this point, yeah, I don't see the point. So program circuit 1. There we go. We are one step away from having this all end-to-end working, which is amazing. So just as a quick recap, we've got the resin printed circuit boards, resistors, and the vacuum tubes all produced now from raw components. So we only have to supply... I should use framed oak drawers, I think. So the framed drawers where we can color them with a different texture. That way we'll know which are the inputs and which are the sort of intermediary ones. So yeah, this one is an input. That one over there is an input. It bothers me that there's copper there and here. I don't know, we might figure out a way to make that better. But yeah, this is great. It's all raw ingredients. Okay, well, let's build this extractor, and then we're going to have to tackle a circuit assembler, which will be its own sub-project, which will be obvious why in a moment. So let's do the extractor. So we built one before, but we forgot what the recipe is. Sometimes it tells you what the problem is, and other times it doesn't. You've got to kind of delve into it. It can be a little bit annoying. So now it's saying, before it said there was enough, but now it's not saying it's enough. Now we need to start exploring. What don't we have? Do we have circuits? Okay, so that's the problem. We only have one circuit. So can we make another circuit? No, because we don't have vacuum tubes. Now, I'm not going to make a vacuum tube. I am going to take the ones that we've already made. 46 of them, in fact. That's huge. Considering I just walked away for just a moment. It's like having a personal assistant just doing the work for you. It's brilliant. Extractor. There we go. I don't think there's anything really much to say about this one. It's just place the extractor down. This is already set to push north. So essentially this just liquefies the whatever you put into it. So in this case tin, and turns it into tin liquid that will go into this machine through this pipe. We need to tell that to auto extract the liquid into there. So let's put some tin in there. Don't think it can take tin dust. I'm just going to test that because it would be useful if we didn't have to cook it first. So let's just try tin dust. Oh, hello. It's working. Oh, that's amazing. Okay. Yeah, that'd be simpler. Let's not do that. Ah, there it is. I missed it. Okay. So are there any benefits? 5.9 seconds. 5.9 seconds. Okay, it's the same. So it's one extra step we don't have to do. So that's brilliant. Is filling up that pipe. So the liquid tin will go into this circuit assembler. So now it's time to tackle that. So the basic circuit assembler. It's kind of daunting. There's a few components that we haven't built before. These circuits and this LV emitter. What is interesting is if we look at our quest tree, we're jumping into MV with this little build. That's why this is going to be difficult. We need 2 of these circuits and we need 1 of these emitters. Let's tackle the emitter first because there's 1. What is the emitter made from? So there's LV circuits, brass rods, tin cable, and quartzite. And we only need 1 of these, so we just need to make 1 single piece of quartzite. So how hard could that be? Looks like one way that we can do it is if we had some silicon dioxide dust with some distilled water in an autoclave, we have a 10% chance of creating quartzite. So since we only need 1, realistically we just need to run this through 10 times and we'll probably get that 1 piece. Do we have any other options? I think that's probably our best option because everything else is running on the assumption that you have the ore. So that's what we're going to do. We're going to have to build an autoclave. And also figure out how to make silicon dioxide dust. An autoclave is probably a useful machine anyway, so let's just build one of those. We're going to need to give it some distilled water. I think we'll fill it from a bucket. So our distillery here, hopefully I can take some of that. Excellent. All right, so we've got distilled water. Silicon dioxide dust. So how do we get that? Aha, okay. Centrifuging glass dust, and we already have a source of that, so that is pretty easy. Is there a cheaper one? We could also electrolyze sand, which is quicker. 1.5 seconds, 25 seconds. Yeah, let's do the glass dust. There we go, silicon dioxide dust. Alright, so this is not going to be too hard to make. So let's get the distilled water. This is a slow process. Oh, okay. Yeah. We're going to have to run this for 10 minutes before we expect to get one single piece of quartzite out. Luckily, we only need one. Let's get this started. Might need more buckets of water. So while that's working, we can start on the next part. So we'll just load this up with a bit more distilled water. So the other thing that we need is we need 2 of these MV circuits. This is how you make one of the good electronic circuits. So copper wire, pretty easy. Electronic circuits, yeah, we've got that sort of under control now. We also need 2 diodes and a phenolic printed circuit board. So let's get the basic electronic circuits sorted. Hopefully these are the last... Oh no, I can't say that. I was about to say these will be the last 6 basic electronic circuits we craft by hand, but I just realized that we're going to need some machines to keep us going with this build. Now we just need the 2 diodes, so we need a total of 4, and the phenolic printed circuit boards. So let's try the phenolic printed circuit boards first. We need 2 of these guys. It looks like we've got silver, so we can make silver foil. Looks like we need a phenolic circuit board as a base. So let's see what we need to build that. We need glue, we need wood dust, that's it. An assembler. Okay, we can do that. Let's make a few of those. How many are we going to need? 2. All right, so let's make some wood dust. Pretty sure we can just put sticks in a macerator. Small piece of wood pulp. That might work for us. We'll see, I guess. Okay, there we go. Wood pulp. Is that going to be what we need? Aha, wood pulp. Awesome. So now we need some glue. Place that in there. Program circuit 1. 50 millibuckets of glue. So that machine's going to have glue in it for a bit then. Amazing. Okay, that's working. So once we have 2 of those, how do we proceed? So we're going to need a chemical reactor from the looks of it. Now, which of these recipes can we do? So silver foil is in all of them. So let's get the silver foil crafted. I think the bender can do silver foil. I think it's 10. Yep, excellent. Okay, so that's the silver foil part of it sorted. We don't have a spare chemical reactor. It might be useful to make one. Okay, got a chemical reactor. It's looking pretty good. We almost got one of every machine now. Now we have a choice. So we need to provide the phenolic circuit board and the silver foil, and then some sort of liquid. All right, sodium persulfate and iron 3 chloride. Now, if I recall correctly, they are actually quests. Quite clearly, this is what this whole tree here is for. So we just need one bucket of one of these 2. So it looks like with a basic chemical reactor, we create sulfur dioxide, sulfur trioxide, sulfuric acid, sodium bisulfate. We're going to need more chemical reactors. Just confirming, so we've got the chemical reactor with silver foil, phenolic circuit board, and some sodium persulfate will make the phenolic printed circuit boards that we need. To make sodium persulfate, we need to start with sulfur dioxide, which is this one here. So it's simply oxygen and sulfur in a chemical reactor, and it produces sulfur dioxide. We then pipe that into another chemical reactor with oxygen, and it changes it from sulfur dioxide to sulfur trioxide. We then pipe that into another chemical reactor with water, and it creates sulfuric acid. We then pipe that into another chemical reactor with salt to produce sodium bisulfate dust and hydrochloric acid. And then from there, with the sodium bisulfate, we can put it into an electrolyzer, and it creates sodium persulfate and hydrogen gas. That is quite a long chain. 4 chemical reactors and an electrolyzer. So the question is, do we build 4 chemical reactors, or do we just bucket this? There's no point building the whole chain. We'll do it by hand, because this is just to get us over the line here, and in the future we'll build this process, I'm sure, for making these other circuits in the future. So one thing I missed out is, how do we get salt? Oh, okay. We can process salt ore and rock salt ore. Okay, I did not know that. That seems like what we should be doing. So we've got some rock salt ore here and some crushed salt ore. Not much rock salt. Why do we have so little of that? That's interesting. Look at all the others are huge, and that one's just 20. It must be a very low chance of getting it. It's a 10% drop chance from sand. Okay, It must be so. Oh, okay, yeah. You look at this. It's in two different spots. Yeah, okay. I've got double up. It's very silly. Very silly. Looks like the salt ore could come into here. I didn't realize that could be processed like that. Okay, yeah, it seems like we're supposed to do this. So let's try taking a few pieces of that and chucking them in here. I'm hoping it will appear in that wall. Oh, wait. No, it won't. It'll appear over here because that's where that output's piped. There we go. So that I'm cool with that. Yeah, okay. So salt can go in there, and then rock salt can go in there. We need to expand this wall. So with rock salt, and we have the borax dust coming through as well. Okay, now I'm wondering if all of these different ores here, the crushed ones, should be running through that cleaning process as well, rather than being stored here. Okay, anyway, we're getting distracted. Let's check on the autoclave. Haha, we have a piece of quartzite. It worked. All right, well, let's do that. Let's craft that piece. LV circuit emitter. Done. So we still need to build this whole sodium persulfate thing. So we got the salt. I did build a chemical reactor, which I did place. We need oxygen. So we can get oxygen by doing some electrolysis. We've got an electrolyzer, I think. Did I build one? No. Okay, let's build an electrolyzer. Done. Okay, so we need to electrolyze something that will give us oxygen. Let's take some magnetite. If we electrolyze this, it should give us oxygen and iron. Okay. We'll have to bucket that out. We need to react sulfur with the oxygen. So let's grab some sulfur. So we should have everything we need now to be able to do this. So there's the oxygen. So I'll grab, I think, 2 buckets of that. I think it's just a matter of doing that. No, what am I missing? Program circuit 2. Okay, sulfur dioxide. So let's bucket that out. Put in some more oxygen. Okay, sulfur trioxide. So put that bucket back in and then put in some water. That'll give us sulfuric acid. Okay, done. Then next we need the salt and the sulfuric acid. Put the salt in there. Program circuit 1. Okay, sodium bisulfate dust and hydrochloric acid, but this is the piece that we want. Sodium persulfate in the electrolyzer. Hydrogen gas and sodium persulfate. All right. Put the phenolic circuit boards, the silver foil, and our bucket of sodium persulfate. Done. It's amazing. Okay. So now we have 2 phenolic printed circuit boards. Okay, so we've got everything except the 2 diodes. So we need 2 of these, so we're going to need 4 diodes. So how do you make diodes? In an assembler using fine copper wire and a small pile of gallium arsenide dust, along with some liquid glass. Because we're using this recipe here, we're going to get 1 each. So we're going to need to do this 4 times. So liquid glass is probably just glass in an extractor. Fine copper wire is pretty easy. And this gallium arsenide dust, we haven't made any yet. So gallium arsenide dust, if I had to guess, in a mixer would be gallium and arsenic. Gallium we have. Now, how do we get arsenic? I'm pretty sure it is from that realgar, which it is. All we've got to do is get ourselves some realgar dust, put it in a centrifuge, and we'll get some arsenic. So the macerator will create impure pile. Forge hammer, same thing. We don't care about the sulfur, so I'm just going to chuck it in the macerator. Sorry, into the forge hammer, because that's quickest. So now that we have some of this, how do we process that? Centrifuge. Easy. Okay. And then we centrifuge that again, and we'll get some arsenic. Centrifuging this is slow, apparently. So while I was waiting for that realgar to process, I looked up the recipes that the electrokinetic ore factory can do, and it seems that the only 2 that we're collecting at the moment that can also be processed through there is the crushed salt ore and the crushed rock salt ore. So I will figure out a way to get these filtered and input into here, I think. The complication is It's because basically everything in here that this is produced with the gravel for these two goes up into that pipe because everything has to be processed. What it means now is some things out of this one here, which goes under the floor and merges here, some of that will have to go into there. So I'm going to have to figure out how I can do that, because I haven't had to do any of that sort of pipe filtering yet. But yeah, it's a learning journey, so we'll figure it out. Okay, how's the centrifuge going? We've got some realgar. Need to run it back through again. How much of this gallium arsenide dust are we going to need? 4 small piles of gallium arsenide dust. I think we already have enough. So let's grab some gallium. Grab some arsenic. I think we need a mixer to do that. Gallium in arsenic. Gallium arsenide. So now that we're going into MV, we can actually tick some of these off for the realgar dust. That one. Sphalerite dust, obviously. Gallium arsenide. So next we have the diode. So the diode, just need to make a small pile in an assembler with some liquid glass. So we've got an extractor somewhere, don't we? No, we don't. Yep, okay. It's always one more machine to build. No electric pumps. Oh, electric pumps are pretty sucky. No pun intended. Done. Okay, so we're gonna need some glass. Oh, got some glass in my inventory already. So if I put one of those. All right, liquid glass. Need to make the gallium arsenide into not tiny piles, small piles. So we need to flush this of the glue, so I think the easiest way to do that is just to break it. So let's put the liquid glass in there, fine copper wire, and the gallium arsenide dust. So we're going to need 4 of these, which I think there's enough in there to do that from the looks of it. I think we'll end up producing 8. All right, we have everything we need. And then we'll just build the circuit. 2 of these guys, 1, 2. Wow, look at that. We just built an MV tier circuit. And here we go. Basic circuit assembler. Place that there. It's already filling up with liquid tin. Tell it to output automatically into there. And now, what we're going to do is load it up with these raw materials that are all around us. So, I think I actually have some of those already, so I'll throw them in. Resistors, some of those. And what else am I missing? Ah, it's probably a circuit thing, isn't it? What am I missing? Ah, red alloy wire. I forgot to build a thing for that. Oh well, okay, we'll have to come to that. How did I miss red alloy wire? Still not crafting. What's going on? Where did I go wrong? Okay. Second assembler. LV, red, oh, hang on, red alloy wire, resistors, resin printed circuit boards, and those. Is it got, oh, it doesn't have power. Okay, yeah, okay, the most simplest of things. All right, let's try that again. All right, the most obvious thing, I had me scared there for a moment. Jeez, after all that work, I'd made a mistake and it just wasn't going to work for us. So we should see. Oh man, that is amazing. Okay, I'm very excited about that. That's been a lot of work. There's 2 episodes worth of work to create that. A lot of planning behind the scenes as well, just to kind of figure out how this whole thing works. But now we're producing basic electronic circuits. We just need to stock this up. So I need to load this up with tin because that's going to run out pretty soon. But the advantage of this, I think, is that the recipe is cheaper because we don't need to cover it in rubber, and we only need 2 red alloy cables per craft, and also no steel. So the recipe is significantly cheaper than crafting it by hand. I think I goofed there by not having a red alloy wire creating things, so maybe I will create another wire mill up here that feeds down into there, or into a chest somewhere. There's enough space up there, just so that we've got all the components here. Alright, so there's some more things we can tick off. So we did the basic cutter, the macerator, extractor, and the mixer. I think I've figured out how to do this filtering thing that I want to do. So what we've got here is this is the gravel processing chain. So gravel is put into the two sieves downstairs and the products come through those pipes and go back up to the electrokinetic ore factory. Over here we have the processing for dust and sand. Now they both go together and end up on the other side of the wall because they don't go through the ore processor. This one above here produces rock salt and salt ore, which can be processed. So what we're going to do is create some chests here. We'll do that. And if we put those in there and then lock it, any crushed salt from above will come in here first because it's the closest destination. And the same for rock salt. If we tell both of these to have the pusher upgrade going down, anything in here will get pushed out. So all we're going to do is hook it up to that part. Be very careful near this edge. All that remains now is to actually get rid of these chests. So that would be automatically coming into this chest here. And then processing in here. Borax, dust, rock salt. Okay. So that's solved that problem. So now seems like a good time to look at upgrades for our chests. So we could continue just adding copper upgrades to the functional storage oak drawers, but there is actually a better chest that we could be using. So there's something called a super chest. As you can see, this is the reason why I didn't want to tackle it earlier, because we need these LV circuits. So steel crate, plates, and long steel rods. So the super chest works very similarly to an oak drawer. It has some built-in features which are very cool. Being a GregTech block, this has a configuration cog, and we can actually get it to auto output. We don't have to apply an upgrade to it. It just comes stock that way. So any of the pusher upgrades that we've had to create for the oak drawers are not necessary with the super chest. It also has the ability to lock it, but also item voiding is included. So if it ever reaches its capacity, then it will just void the items. By far the best thing about the super chest is its capacity. So the super chest has a capacity of 8 million items. It might be worthwhile upgrading some of these. This one here, the tin storage is looking pretty bad. Let's grab some of this, put that in there, lock it, disable item input from the output side. Because if I turn that on, that means items can come in through the back. And now it's just a matter of doing a switcheroo. So let's grab that and grab that. And now that, as you can see, is already filling up. Now we're going to have to figure out how to get that into there. I guess we could put a pusher upgrade into it and just stick it next to it. Give this guy a pusher upgrade for south. Put that in. Pick that up. Put it there. And that should now be filling across. It'll take a little while, but that will work. So here's a good example. A tiny pile of sulfur dust. I actually don't want that. We get enough sulfur from everything else we do. This is something that I don't care about, but I don't want it filling up my storage. It would be worthwhile building a void upgrade for that one. I'll put that in there. That should stop it from overflowing into other chests. Because obviously, if it couldn't find a spot to place the tiny pile of sulfur dust in here, it would start putting it into the big chest downstairs and just fill that up. And we don't want that. Item voiding is important because otherwise it would just fill up your entire storage system. In this episode, we've made good progress into MV. I wasn't expecting to do that. I didn't realize the basic circuit assembler was part of the MV tier until we actually started heading towards it. LV is looking pretty good. There's a few nodes here we can tick off. A fluid solidifier might be useful. And the gas collector, if we need to get oxygen, we will probably use electrolysis, but nitrogen, that would be an easy way to get some of that. What does tempered glass require? Tempered glass just requires oxygen. So there's basically this section through here is all going to be about oxygen. So we'll build an oxygen manufacturing plant, probably electrolysis of magnetite at this point. I don't think words can convey how happy I am that we've built this machine here that creates these basic electronic circuits. It's quite an achievement. There's a lot going on here. And this is just the beginning, because we are going to have to create something like this for pretty much everything going forward. So I think that just about wraps it up for this episode. Next episode, I think we're going to tackle the electric blast furnace, because we're going to need aluminium and signalum and various other things that can provide us. We're going to need those as we head into the MV tier. I really appreciate all the support that I've received. I've been getting some really good feedback in the comments. Thanks for watching, and cheers!